Galileo Galilei by Emily de Dwyer. This summer, I visited the burial site for Galileo in Florence, Italy, and was very curious about his attributions to physics, so this project gave me the perfect opportunity to explore that interest. Towards the beginning of the semester, we talked a lot about kinematics, but never really who came up with the equations we consistently use. This project is meant to be an exploration of that. Galileo was born in Tuscany and studied at the University of Pisa. Originally, he wanted to study medicine, but soon realized his love for mathematics. So, against his father's wishes, he decided to explore this over medicine. This didn't last for long, though, because Galileo ended up dropping out of college and dove right into studying kinematics, which he continued to do for about 20 years. He was very successful throughout these years and was able to publish many different papers on his findings. Throughout his career, Galileo faced many different challenges. When exploring motion, he was going through what Aristotle had proposed and realized that he was incorrect. Galileo, unlike Aristotle, believed that the speed at which a heavy object falls is the same at which a less heavy object would fall. This made him very unpopular with the people he was working with at the time, and he ended up losing his job. Additionally, later on in his career, many of his papers were banned by the church, as they felt as though he was spreading lies. It wasn't until 102 years after his death that the church admitted they were wrong. As I discussed in the previous slide, Galileo helped everyone understand that gravity has a constant acceleration. It is said that he did this by dropping two balls with different masses off the Leaning Tower of Pisa and was able to show that the balls fell at the same speed and that Aristotle was incorrect. This was one of his many contributions to kinematics. Another one of Galileo's many contributions to physics is his law of falling bodies. This law established a relationship between time and distance traveled, which he discovered when doing an experiment. In the graphs below, there is a model of the data that Galileo collected while doing this experiment. Galileo found that the distance traveled is equal to the time squared, which can be seen on the graph to the left. Additionally, he found that velocity increased at the same rate as time. This can be seen by the linear relationship in the graph to the right. Using the experiment I just described on the previous slide, Galileo was able to formulate these 5 different kinematic equations that to me are the backbone of physics. Through doing this, Galileo was able to pave the way for people like Isaac Newton and therefore really helped in the advancement in our knowledge of physics. After the discussion about Galileo, his life, and his contributions to physics, here's a real-world example that I created. You can see that using Galileo's equation for change in distance, you're able to solve for change in time. I used the height of the basilica and the fact that the acceleration due to gravity is 9.8 meters per second squared to find that if we dropped something from the top of the basilica, it would take approximately 4 seconds to reach the ground. So even when given little information, Galileo has given us the tools in order to solve for many different variables.